Hi, welcome back to Leetcode. So in this video, we discuss the Leetcode problem 3751, total waviness of numbers in range 1. So you are given two integers num1 and num2 representing an inclusive range num1 to num2. Okay. The waviness of a number is defined as the total count of its peaks and valleys. So what is peak? So a digit is a peak if it is strictly greater than both of its immediate neighbors. Okay. A digit is a valley if it is strictly less than both of its immediate neighbors. Okay. One is that greater than both of the neighbors, and valley is that strictly less than both of its neighbors. Right. So the first and last digits of a number cannot be peak or valleys because two neighbors is not present. Only one neighbor will be there, right? For the first and last digit, so we can't take any decision. So that's why they will not be create anything. It will not be a peak or it will not be a values also. Any number with fewer than three digits have a waviness of 0. Okay. So that means if the string length or the number length is less than 3, so there cannot be, we can take any decision. So the waviness will be 0 for that number. So we have to return the total sum of waviness for all numbers in the range of num1 to num2. So let's see the example one, then it will be more easy to understand what they're trying to say here. For that, num1 is 120 and num2 is 130. Okay. That means we have to count 120 to 130, correct? So first of all, I have to count the what is the waviness for the number 120. So 120. So for one will not be 1 and 0, first and last digit will not be create any uh, peak or valleys. So the middle one, the 2, is it actually creating any peak or valley? So 2 is greater than 0, 2 is greater than 1, both of its neighbors. So that's why it will create a peak. Great, correct. So that's why for uh, for this number, firstly largely cannot create any peak or value. Yes, yes, strictly greater than both of its immediate neighbors, so it will create a peak. Correct. So for this number 120, waviness will be will be increased by 1. Waviness is 1. Okay. Next, I will count 121. So similar way for this 2, 2 is greater than 1 and 2 is greater than 1. Yes, this is creating a peak. So again, waviness is 1. Next number is 122. So for this 2, 2 is greater than 2. No. So it will not create anything. Any other digit is possible who actually have two neighbors? No. So that's why for this waviness will be 0. Next I'll go to the next number 123. Similar way for this 2, 2 is greater than 3. No. 2 is greater than 1. Yes, but both should be greater than the current number or the middle one. So that's why again the waviness will be 0. Correct? Next number will be 124. In this we will continue up to 130. Okay. And for each number I'll get one waviness value. Okay. And I will actually ultimately add this to the answer. Okay. What are the waviness for the current number I'll get? So we can actually use the brute force approach here. Why? Because they mention that maximum number it can actually have 10 to the power 5. Okay. So if actually compare with the character by character, then the maximum length will be 10 to the 5, 1, 2, 3, 5. So maximum length actually it is 6. Correct? Maximum 6 character will be present. 1, 2, 3, 4, 5, 6. 6 character. So suppose there is 10 to the 5, each number I have to convert, I have to traverse. So means 1 to 10 to the 5. So total number I have to traverse 10 to the 5, and for each number I have to traverse each position maximum 6 times. 6 character will be present. So this will be 6 into 10 to the 5. Clear? Each number can actually maximum 6 character, and I have to traverse all the numbers means 10 to the 5 numbers, and each number average length if you took the maximum length 6, then it will actually 6 into 10 to the 5 times time complexity. So it is less than 10 to the power 8. So that's why it will work. Brute force approach will work. So what is the condition to calculate the waviness? First condition is that I will check the length of the number, length of the any number. Okay. If it is less than 3, I will return 0. Because they mention that if the string length or the number length, if any number with fewer than 3 digits has waviness is 0. Correct? So that's I'll check that if the string length or the number length is less than 3, I'll return 0. Else I will take one count 0. Okay, now I have to start from the middle one, means I is equal to 1, 2, and it can go up to n minus 2. Why n minus 2? This is the middle one. Okay, so index 1, 0, 1, 2, 3, 4, 5, suppose in this way. So 1 can actually have first digit is the index 1, which actually have the two neighbors. Here actually also we have index 0, right side also we have index 2. Both actually, it actually have two neighbors, right? So that's, and it can go up to n minus 2. Suppose 5 is the last index, so it can go up to 4. Why? Because this is the last index, we actually have the two neighbors. Clear? That's why it will go up to 1 to n minus 2. Okay, now we actually have three character. One is the at index I minus 1, suppose B, and another will be at the index I. Okay, another is the right neighbor, that means I plus 1. Correct? So I'll choose that, I'll check that this is the three character actually I have, left side the current element and the right side right element. Now I'll check that if B is greater than 1 and B is greater than C, the middle number B is greater than both the neighbors. So then actually our answer, this actually create a peak. Correct? And this will actually increase our count plus plus. Correct? And another condition also, we actually can actually increase our waviness if it is the creating any valley. What is the condition for valley? B less than A and B less than C. Then actually create a valley. Then also our count will be, or the waviness value will be increased by 1. Clear? So I'll check that this with using these three character A, B and C, is it creating any peak or valley? If it is true, then actually our count will be increased by 1. And ultimately after checking all the position, after each character, after each position, I will have the final count value, that will be our waviness for this current number, and I'll return that. Okay, in this actually I will actually check all the number. Correct? Clear? Now go to the code. So first of all, our answer is a total waviness. We would return a total sum of waviness of all the numbers. So that's why answer is 0. Okay, and our number will start from num1 to it can go up to num2 inclusive range. So that's why I'm starting from num1 and less than equal to num2. Okay, so now we have to calculate the waviness for this current number I. Okay, so I'm passing this into this another function, calculate waviness for this current number I, and this will return the total waviness for this current number, and I'll add this into the total sum answer, because this answer is stored the total sum of the waviness of all the numbers. So that's why let's see this and ultimately return the answer after that, after checking all the numbers. Okay, so this calculate waviness function, it will take one number, for which number actually we want to calculate the waviness. First of all, convert this to the string. So I'm converting this to string into the temporary, as a name is temporary temp. They mention that if the less than 3 digits is present, then waviness is 0. So that's why if our string length is less than 3, then return 0 directly. Okay, else we actually have some count, the total number of peak or valleys we can have in this current number. So initially it is 0, and I am starting from I is equal to 1. I have already explained why actually it is starting from 1, because this is start first index 1, which actually have the two neighbors, index 0 and index 2, and what is the last index, it can go up to n minus 2. That's why I will go up to I less than n minus 1, means it will go up to n minus 2. Clear? And I plus plus. Okay, now we actually have the three character A, B and C. A is the left neighbor of this current index I, that is temp of I minus 1, and B is the current character temp of I, and C is the right neighbor of the current index I. So C is the temp of I plus 1. Got it? So if b is creating any peak or valley, what is the condition to for that? For peak, the b should be greater than, strictly greater than both the neighbors, strictly greater than. So that's why here actually you can see that b is strictly greater than a, b greater than a, and b greater than c, both the conditions should be true, then actually we can create a peak, right? Or both should be greater, small, or the b is smaller than, strictly smaller than the both the number, then only it will create a valley. So or the condition is the b is smaller than a and also b is smaller than c. If both the condition is small, true, then actually it will create any valley. So if it is creating any peak or valley, then actually I will increase the count, because they mentioned that um, total count of its peak and valleys. So I have to count that either peak or either valley. So if it is if one of this is true, then actually I increase the count. Okay. So after this for loop, I actually have the count variable, which actually indicates the total number of peak and valleys actually I have seen in this current number. So return that. That is actually the waviness for this current number. Got it? So here actually you can see that this for loop will run n times, means the range, the number of range. And for this, each time we are calling this function calculate waviness. This function actually, another for loop is present, that is the length of the input number. So length of the input number maximum is 6. So that's why it can go up to maximum 6 time it will run for each number. So that's why 6 into the number of n, 6n. Got it? Clear? So if this is clear, I have shared this code in the description. You can check that. You have any doubt, any suggestion, you can comment on that. And if you not yet subscribed, please subscribe channel. And if you like the explanation or the tutorial, please like the video. Thank you. Bye.